EMF and terminal voltage. Okay, so we have a setup here in our picture where we have a battery that has an EMF or electromotive force of 12 volts and it has an internal resistance of 0.5 amps and there's another resistor that's 65 ohms. Now, important thing to consider, battery voltage is never constant. It's a chemical process. That's why you could see voltage drops like on your battery when you start your car, like the lights dim. There's internal resistance. The process isn't instantaneous like it, or continuous or constant like it would be, say, on a 12 volt motor where it puts out a continuous voltage for the entire length of time. So we have to deal with that. So our EMF is 12 volts. And so that's the idealized voltage when you start. So, and notice that EMF is not a force measured in newtons. A good analogy for a battery is like a pump that pumps current around the circuit. Alright, so all that aside, the EMF is 12 volts. So notice that these two resistors are really in series. So I could say the equivalent resistance is the sum, or 65.5 ohms, right? So that means using Ohm's law, or V equals IR, I could find the equivalent current in the circuit. So I could take the 12 volts, the EMF, divided by 65.5 ohms, and I get 0.1832 amps, not paying attention to sig figs. Okay, so that's what the current is. Now remember, in series, the current at both points is the same. So, what's the voltage at the 65 ohm resistor? And what's the voltage at the 0.5 ohm resistor? Right? Well, at the 65 ohm resistor, I could just do IR. So I could do 0.1832 amps times 65 ohms, and I get 11.9 volts. Okay, and I could do the same thing. I can do here, and of course I get 0.1 volts because they have to add to 12, right? So now what would be the power in each resistor? So the power at the 65 ohm and the power at the 0.5 ohm resistor. Well, remember, power is just IV. So I could just do the current .32 amps times 11.9 volts, and I get 2.18 watts. And I could also do the power in that one, and I get about 2.19 watts, give or take. So they put out about the same amount of power. All right. Now I'm going to do a part 2 of this video, and we're going to look at how your textbook wants you to look at this.